Okay, rational exponents. This is when you have a base. I'm just going to call the base A. The base can be 2, 3, 4, 5. It could even be a negative base. When I have that base, I'm going to raise it to a fraction, m over n. Now, what we're going to learn today is how to rewrite this. So, the way you rewrite it, going back and forth, is radical. That A stays A. The base stays the base in both cases. The numerator, m, becomes the power. The denominator becomes the index. It looks like that. Okay, so we call that the power or the exponent, and that is the index. And when you rewrite it, the number at the top is the power, the number at the bottom is the index. You will need to know this. We're going to be doing this quite a lot today. You will need to know the names. One of these is called exponential form, and one of them is called radical form. What do you think this would be called if it has no radical in it? Would it be exponential form or radical form? This one is the exponential form, which means the second one must be what? The radical form. And a really quick side note on this one here is you may see this written, this one right here, as the nth root of a to the m power. What's the difference between these two as far as the m exponent goes? Anybody see the difference? This one's inside and this one is outside. Does it matter? It does not. You pick it. If you see it this way or this way, no, they are the same thing. All right, so don't get confused when you see it change here and there. All right, we're going to go pretty quick here. Write in radical form. That's all I want you doing is rewriting. We're not simplifying or evaluating anything. Write in radical form. Number 1, x to the 2/3. Okay, so I'm going from exponential form to radical form, which means I'm going to have a radical in it. The base is going to stay the base, x. Now what you have to figure out where the 2 and the 3 go. What goes here in the index? The top number or the bottom number? The bottom, the denominator, the 3. What goes as my exponent? 2. I'm going to put on the outside for now, but would it matter if I put it x squared on the inside? No. And that's it. You're done with that problem. Do you agree that was pretty easy? Okay, next one, k to the 1/3. Radical, base is k. What is the index, 1 or 3? The 3. And what's the power? Does it matter if I put it inside or outside? Now technically, do I have to write a power of 1? It's okay checking answers and say the answer key has it like that, or it's multiple choice on the test, or is that the same thing as having a power of 1? Yeah, you should know that. Okay, number 3, m to the 1/2. Radical, base is m. Amelia, can you tell me what number goes right here, the 1 or the 2? What was that? You can see from where you're sitting? Was it like this yesterday as well? Okay. I'm going to have you just grab that desk and move up closer. Okay. Audrey, do you mind answering it then for this one? What goes right here? The 2. And what goes as the power? Do I have to write it? Is it okay if you do? There's some desks there. Just pull it up close where you can see. Okay. I want to talk about rewriting this one, because you will not see an answer written this way on a test. If this was a multiple choice question, you would not see the answer written like this on the test. So, is everybody listening? Do you remember when we did worksheet 4, our first day back from break? what did I keep saying on these here? I said, oh, there's a little something here, but we never write it. What was it? Do you guys remember? A 2. The exponent's always 1, but the little index here was always 2. That's what we call it, the square root. Square root because it's 2. This, the cube root, because it's 3. Got it? So I'm going to repeat that again. When you have a radical like this with no index, it's implied to be a what? A 2. Do we ever write it? No. So when you have the 2 there, is it necessary? This is the way you're going to see it written. Should you know that these two things are the same? The square root of m to the first can be written just as the square root of m, without the 2, without the 1. You need to know that. Number 4, 5 to the 3/8. I'm going to have you try that one on your own. All right, let's call on Desi. How do I write it? The 8 as the power or the index? Okay. Did you put yours outside or inside? And does it matter? So if you wrote yours outside and I put mine in here, would that be the same thing? Yes. All right, thank you. Okay, questions before we go the other way? Okay, write in exponential form. Number 1, the cube root of g squared. This is radical form. I want you to change it to exponential form, which means g is going to stay g to what power? It's either going to be g to the 2/3 or g to the 3/2. And I'm calling on Grace. Grace, can you tell me what it would be?
I did g to the 2/3.
Does everyone agree with her? Yes? G to the 2/3. Thank you. Number 2. The 7th root of 8 to the 3rd power. This power I put on the inside, this power I put on the outside. Does it matter? No, so know that. So go ahead and do it. And I'm going to call on Serenity. Can you tell me how to rewrite it? 8 and 3/7 or 8 raised? Say it again, I didn't hear you. The exponent raised to the? Thank you. I didn't hear it the first time. Thank you. 8 raised to the 3/7. Do you guys agree or disagree? Thumbs up, you agree? Okay, number 3. Hoods off in class, please. Hoods off in class, and your earphones and your cell phones put away. Now, I didn't say this one purposely. How do we say this one? Yes?
Would it be x to the second power?
Okay. Exponential form. You're on the right track. Can you said x to the second. Can you tell me where you got the 2 from?
Because squared.
There's a 2 right here?
Yeah.
Yes. Do you guys agree when there's nothing there, we call it the square root, which means there is a 2 there. Yes or no? Yes? I do need this number here because it's the power over the index. So what's the power here that I don't see? 1. So you need to know when you see a square root, it's not going to, and there is no power. You need to put that a 1, that a 2. So what is it? Can you fix it now? X to the what over what?
X to the second over 1.
Not to this, it's the other way around. X to the 1 over 2. There you go. Good job. X to the 1 over 2. Power of 1 over the index. Make sense? All right, number 4. This next one is a little tricky. because there's still only one term on the inside, but there's multiple pieces or multiple variables and numbers on that one term. Do you see it? Yes? Okay. On this one, I want to ask the question, what do you think? Would it be okay for this 3 to go inside or outside? Let me take a step backwards. Is this 3 applied to the 2, the x, and the y, or just the y? Just the y. So now that we've clarified it, would it be okay to put the 3 on the outside? No, because the 3 on the outside is saying what? It's applied to all of them. You guys need to listen because this is on the test. So the question again, can I put the 3 on the outside? No. All right. In that case, we need, remember in the lesson we had on block day, I need to put my little exponents in. What exponent do I have on the 2 that I do not see? And what exponent do I have on the x that I do not see? And then you write them all individually as a fraction. 2 to a fraction, x to a fraction, and y raised to a fraction. Now, I haven't told you how to do it, so do I have a volunteer that's willing to throw out what you think it might be? Or should I call on someone? No volunteers? All right, I will call on Andrew.
2 over 1, or 2,
Raised to the
1 over 4.
2 raised to the 1 over 4. Good.
And then x raised to the 1 over 4. And then y raised to 3 over 4.
Good job. Did anybody else, even though you didn't raise your hand to volunteer, did anybody else do that on their own or know how to do it before I wrote the answer down? No? All right. That's how you do it. He is correct. X, or 2 to the 1/4, x to the 1/4, and y to the 3/4. Questions? Okay. Now is when they start to get a little bit harder, and they get harder as we go, so you want to make sure that you are paying attention. Evaluate. Number 1, 9 raised to the 1/2. Now we're actually going to simplify, evaluate, get an answer, like a number answer. Ask a question first. Is this exponential form or radical form? This is exponential form. If they're asking you to evaluate, you're going to change it to radical form. So let's do that now. Radical, what goes on the inside? The 9. What goes as the index, the 1 or the 2? And what goes as the power? Technically, do we need to write the 2 and the 1? No. In your head, this is what you should be processing. Do you guys agree that's the same thing? Let's do it this way. Square root of 9, what's the square root of 9? 3. So I end up with 3 raised to what power? First. And what is 3 to the first power? Would I get the same thing if I just saw it that way and asked you what's the square root of 9? What's the square root of 9? And you'd be done. So that extra power of 1 is just an extra step, not necessary, but it's okay if you do it. All right, number 2. 25 to the 3/2. Radical. Carrie, can you tell me what big number goes on the inside, my base? The 25. Can you tell me what goes here as the index? The 2, it's okay. And the power? The 3. Now, what have I been saying about the 3? Does it matter if it's inside or outside? Does it matter? Okay, before you work ahead of me, please just listen quickly. If you're the student who writes it inside, or if you come across a question on a test or a quiz or a worksheet and it's written this way, the square root of 25 cubed, I will tell you, it doesn't matter. You could do 25 times 25 times 25 and then break all that down. But it will always be easier if you do the index, the radical piece first, and the power at the end. It will be easier if you do this piece first, the radical piece first, and the power last. The order technically doesn't matter, but it's typically easy to do that first. Can you guys do that without any breaking down? That 2 means the square root. What's the square root of 25? 5. Without breaking down, do you all agree it's 5? Is 5 my final answer? No. What power is it raised to? That third power is still there. So now it's not 5 times 3, it's 5 times 5 times 5. Can you guys calculate that, please? 125. And this is one of the other reasons you can't use your own scientific calculators on the test, because some kids know how to plug that in, which you can do, and get an answer. It will work. So you'll be required to use the baby calculators on test day and quiz day. Okay, 27 to the 1/3. Rewrite it. Cole, can you tell me how to rewrite it?
Put the 27 inside of the and then the 1 goes next to it. It's the power of 1. And the 3 is
Right there?
yeah.
Okay. Do you guys agree with them? We save the power for the end. That power of 1, he put it in the correct spot. Is it necessary? No, I'm going to leave it. Cube root of 27, you either know it or you break it down. What does 27 break down into? 9 and 3, and 9 is 3 and 3. So I have the cube root of 3 times 3 times 3 to the first power. The 3 tells me to circle in chunks of 2 or 3. Is one whole set coming out? Is anything left inside? If one whole set comes out, there's no more radicals. So what's my final answer? 3 to what power? 3 to the first, which is just 3, which again is the reason you don't have to write the first power out. It's okay, but it's not necessary. Number 4, 81 to the 3/4. I'm going to have you guys try that one on your own. 81 to the 3/4. Rewrite it, break it down, take out your pairs or whatever chunks, and then raise it to whatever power in that order. Rewrite it, break it down, take out your chunk, and then raise it to the power. Anyone else want a calculator? Gotta remind you guys to get them. Please, anyone else back who need a calculator? Everyone have one? Yeah. All right, some of you guys are still working, which is good, but I just want to show you rewriting. Did you guys get this? 81, sorry, not an 84. 81, the 4/3 of 81 to the 3rd power, yes or no? Then you're doing this first by breaking down. All right, do you guys have this? 81 breaks down to 3 times 3 times 3 times 3, yes or no? Okay, so I'm doing this part first. What chunk, does a whole chunk come out? Yes, so there's nothing left. It all comes out as what? Is 3 my final answer? No, it's 3 to what power? Which means 3 times 3 or 3 times 3 times 3? Which is 27. Good job, guys. All right, number 5, 8 raised to the 2/3. I'm going to have you try that one. And I want to change it. Sorry, 8 to the 4/3. All right, did you guys end up with enough numbers to come out as one chunk? How many do I circle at a time? 3. Is there enough for exactly all of them to come out? Is 2 my final answer? No, it's 2 to what power? And 2 to the 4th is not 2 times 4, it's 2 times 2 times 2 times 2, which is 16. Good job. All right, questions before we move on? All right, so now is where we're going to get to the slightly harder ones. So I'm going to try to go a little slower, make sure you guys are paying attention. Parentheses, negative 32 raised to the 3/5 power. Number 7 is 64 raised to the negative 2/3 power. All right, the reason I wrote them both down is to show you the difference between these two. They're both written in exponential form. This one has a negative base and this one has a negative exponent. Do you see that? Is there a difference? Big difference. Negative base versus a negative exponent, those two things are different. Okay, let's just start this one off and see what happens. Radical, negative 32. Index is 5, power is 3. All right, we have a negative. Ignore the negative for now and just break down the 32. I'm going to have you guys start there. Ignore the negative and just break it down. How many 2's did you guys end up with? 5. Okay, so 5th root of. Now, whatever's in here has to all be positive or all be negative. Is there any way to multiply 2 times 2 times 2 times 2 times 2 5 times and to have it be negative 32 if they're all positive? No. If I have negative 2 times negative 2, 1, 2, 3, 4, 5. If I have 1, 2, 3, 4, 5 negative 2's, they're all negative. When I multiply them together, will it end up being negative 32? Why? Because there's an odd amount. Those are positive, leaving us with a negative. Do you agree? Okay, so what's the 5th root of negative 32? It's not just 2, it is negative 2. Whenever you're taking like the 3rd root or the 5th root of a negative, the base is going to stay negative. If you're taking the 3rd root or the 5th root of a positive, it's going to stay positive. Does that make sense? Yes? All right, so you could only take odd. This number has to be odd, like a 3 or a 5, in order for the base to be negative. Don't worry that we're not going to trick you on any of them on homework or quizzes or tests. All right, so if the base is negative, your answer is negative. What's the exponent? 3. Negative 2 times negative 2 times negative 2. What is negative 2 times negative 2? Times another negative 2? Negative 8. Okay. I'm just going to do a what if. Don't write this down. What if this exponent was a 4? I'm just going to erase it. Don't write it down because I'm going to put it back to the 3. If that was a 4th power, I would have another -2. And what would it come out to be? Positive or negative? If I have 4 negatives. It would come out to be positive. Does everyone agree with that? Okay. Or if this was a squared, is -2 times -2 still a positive? Okay, what was it to begin with? 3. So when it was to the 3rd power, it came out to be negative. Can anybody tell me about even, odd? When would it come out to be negative and when would it come out to be positive? Can anybody see the pattern? If this is 3, 5, or 7, what kind of answer are we going to end up with? Negative. What would this have to be a positive answer? Even. 2, 4, 6, 8. We're going to end up with a positive answer. Questions? So when we have a negative base, write this down, when there is a negative base, and by negative base, I mean that guy right there being negative. When there's a negative base, the answer will be positive or negative. I'm going to leave a space, negative. All right, and in those little parentheses, I'm going to write down, I want you to do the same. When does it come out to be positive? When there's a what exponent? Even or odd? Even. When does it come out to be a negative number? When the exponent is odd. All right. Now, I'm taking my time on this one because this is where kids start to mess up, when we throw these negatives in there, so you want to be careful. All right, next one. Before I do 7, any questions on 6? All right. Radical, 64, index of 3, power of -2. Your exponent always goes to the power, never the index. I'm going to put a little bubble here because the worksheet writes it like this. Let's see if I can get it in there. With the negative right in the middle. And I often have kids say, where does the negative go? On the top, on the bottom, on both? Should that negative go to both of them? No, because what's a negative divided by a negative? Positive. And is that a positive fraction? So I'm going to ask the question again. Should that negative go to the top and the bottom? No. What did I just say a second ago? Always put the negative where? Top or bottom? Top. Never put it on the index, put it on the power. So on your worksheet tonight, when the negative's written that way, where are you going to tag it on? Top, not the bottom. All right. Break down the 64. Go ahead and do that now. I think that breaks down to a lot of 2's. Keep going. How many 2's? 6. Positive or negative if the base is positive 64? That's going to be positive. Don't worry about the negatives unless the base is negative. So you said 6. Do I have enough for all of them to come out? Let's see. 1, 2, 3. What's 2 times 2 times 2? Oh, gosh darn it. And I wrote in pen. Thank you. Perfect example of don't go too fast the way I was going here. And thank you for catching that. We should be circling in chunks of what? 3. All right. I'm going to use a different color. 1, 2, 3, 1, 2, 3. Do we have enough for all of them to come out? Yes, so it's not 2 times 2 times 2. It's what times what? 2 times 2, which is 4. And is 4 my final answer? No, what are we raising to? -2. All right, we just went over this lesson yesterday. What's 4 to the negative second? Is it negative 16? This does not, and don't ever say it does equal negative 16. It does not. It does not. The negative exponent means you move it where? Do you guys remember? To the bottom. 1 stays at the top, and it becomes 4 to the positive 2. So what's my final answer? 1 over 16. Okay, so what's the difference? Negative base, we do our work as usual, and our answer comes out to be positive if there's an even exponent, and negative if there's an odd exponent. The difference here is this is a negative exponent. Did my answer come out to be negative? Will my answer ever come out to be negative? No, unless the base was negative, which it's not. When the exponent's negative, let's write that down. When the exponent is negative, your answer will be a fraction, a positive fraction, unless your base was negative to begin with. Fraction answer, not a fraction answer. Negative answer, not a negative answer. Know the difference. All right. Questions before we move on to the last little piece of our notes. Okay. This is going to use what we just learned with stuff we went over on block day. 36x squared raised to the 1/2. 36x squared raised to the 1/2. Did we do this lesson yesterday? Block day. Yes. There's no plus or minus inside, so am I allowed to distribute the exponent? Yes. What do I put on the 36 first? Do you guys remember that from yesterday? Little power of 1. And then we distribute. So I don't do 36 times 1/2. I do 1 times 1/2. 36 raised to the, what's 1 times 1/2? 1 times 1/2 stays 1/2. X, and then here you're going to do 2 times 1/2. What's 2 times 1/2? 1, because it's 2 over 2, which is 1. Can we simplify this piece? What does a 1/2 power mean? Do you guys remember what the 1/2 power means? What goes here? What's the index? 2. Do I have to write the power of 1? I'm not going to. What's the square root of 36? Without breaking up, what's the square root of 36? What's the final answer? And that's it. Make sense? All right. Let's try another one. Number 2. 8x to the 6th raised to the 1/2. All right, what do I put on the 8 right here? A what? A 1. And distribute. Go ahead and do that now. Eight to the 1/2, because 1 times 1/2 is 1/2. X to the, what's 6 times 1/2? 6 over 2. Can I reduce that? What does 6 over 2 become? 3. You rewrite this. 8 to the 1/2 is the same as the what of 8? The square root of 8x cubed. Is 8 a perfect squared? Yes or no? But can you break it down and take out pairs? You sure can. Go ahead and do that now. Simplified radical form. Now remember, the x cubed is not inside the radical. That is out. So you're not breaking up the x. You're not breaking down and taking anything out. What comes out of the square root? 2, and is there a 2 left inside? Yes? So what does a square root of 8 simplify to? 2 root 2. Good job. 2 root 2, and then the x cubed stays. Guys, you can see why this is going to be a hard test. There's a lot of concepts, and we're still not done, like learning new stuff. So you want to make sure that you understand. All right. How about this next one? 2 raised to the, I'm actually going to change that. 3 raised to the 1/5 times 3 raised to the 3/10. All right, we did this yesterday. When I'm multiplying like bases, what do I do to the exponents? Add. Do I multiply the bases, or will this base stay 3? The base will stay 3. What you're going to have to do is thank your elementary school teachers for teaching you how to add fractions way back when, and do that now. Do you guys remember this from elementary school? What's the common denominator? 10, so this is going to stay 3/10. 5 times what is 10? 2, so I multiply the top by 2. 1 times 2 is 2. Do you guys remember that right there from elementary school? Adding fractions. Even if you hated it back then, we still need to remember how to do it. What's 2/10 plus 3/10? And if you can reduce, you do have to. What is 5/10 reduced to? 1/2. Now, I didn't write it up here, but it will tell you on homework to write in radical form. So would I get it wrong if it says write in radical form and I left my answer like this? Why? This is not radical form. This is what? Okay, so radical 3, what's the index? What's the power? Are you ever going to see it this way on the test? No. Square root of 3 like this is how you're going to see it. Questions? Do you agree this is review but added on with the new stuff that we just learned with fractions? All right, one other one, or actually 2 more. Number 4, 7 to the 1/2 times the square root of 7 cubed. Now I kind of gave this as a freebie, but typically will that 2 be written there? And when that 2 is not there, should you know it's a 2? Okay, what I need to do, guys, is add the exponents. Does anyone know what I'm going to have to do with that one there in order to add the exponents? You have it? Anyone know? Change it to which form? Can I make this whole problem look like this one here? Yes. 7 to the 1/2 times 7 to the 2/3. Do you guys see how that works? 1/2, 2/3. The base is going to stay 7. What's the power going to be? What do you do with the exponents?
Isn't it 3 over 2?
Thank you. I love it when you guys are paying attention. And that's what I get for going too fast. Did anybody else catch that and not say it? Okay, thank you guys. Speak up, speak up. Please don't be afraid. 7 to the what power? 3 over 2. All right. Do I have to worry about a common denominator? Is it already taken care of? What's 1/2? I didn't finish my plus sign. Plus 3/2. 4/2. Can I reduce that? 7 what?
7 squared.
Squared, which is, and there's no radical form on this one. It will say write in radical form when necessary. I can't change that to radical form. It's just 49. All right, now we're ready for our last one. Are you guys ready? This one is probably one of the ones kids struggle with the most on the test. X to the 1/3, and I'm going to put a 5 here. Anyone want to take a shot at that? No one? Okay, it can get kind of confusing. I'm going to show you one way, give you a shortcut. It's up to you. What's the power here? I know the 1/3's there, and I'm going to leave it there. What's the power out here if I wanted to add 1? What would it be? So I'm going to write this as x to the 1/3 raised to the what power? 5/1 or 1/5? And what do we do with the power to a power? Multiply or add? So you're on the side going to do 1/3 times 1/5. Do I need a common denominator for that? Do I need a common denominator when multiplying? I see a few of you nodding no. No, I do not. What's 1/3 times 1/5? So you end up with x to what power? Radical form, because we're still in the radical form section. Radical, the 15th root of x to the first power. Do you guys see how that worked? Sometimes you will leave it like that. It'll say leave an exponential form. That's your answer. If it says change to radical form, then that's your answer. Know that it's going to ask for either one. Does anyone want to hear the shortcut really quick? When you have a fractional radical problem, what's 5 times 3? What's 5 times 3? 1/15. That's another way to think of it. It's up to you and how you do it. Any questions?